Hello, I am Scott Yano, Vice President of Product Development here at Lakeshore Cryotronics, and today we're going to go down to the research lab to offer you a quick look at Lakeshore's Cryogenic Terahertz probe arm option.
Lakeshore's Cryogenic Terahertz probe arm option is the first commercially available solution for on-wafer probing of samples at terahertz frequencies within a cryogenically cooled environment. The probe arm works in several of our Lakeshore cryogenic probe stations. Here we have a CRX 4K station, and now gives researchers a way to test structures at frequencies greater than 67 gigahertz in vacuum and variable temperature environments down to cryogenic temperatures. This product was years in the making and is made possible through our collaboration and partnership with several other companies, including Virginia Diodes, Dominion Microprobes, Swiss-to-12, and Cascade Microtech, and with the help of the University of Virginia, where initial prototype testing was done. All of them played a role in helping us overcome one key major challenge, and that's getting the high-frequency signal from the frequency extender that has to be outside of the probe station to the device under test inside the cryogenic environment. It's a challenge because as frequencies extend beyond about 100 gigahertz, the signal losses are very high, even using traditional low-loss waveguides. We're talking about paths as short as just a few centimeters before the losses become appreciable. In probe stations that operate at room temperature, this isn't much of an issue because you can connect the VNA extender head right to the probe, keeping the distance that the high-frequency signal travels very short, maybe to only a few centimeters. In a cryogenic station, however, the VNA extender head has to be outside the vacuum chamber, and from there, the high-frequency signal has to propagate through the bellows, through the thick shell of the vacuum chamber, through the cryogenic radiation shielding before it can get to the internal probe and the sample itself. This distance can be on the order of about 25 centimeters, and this is a real challenge for those losses that degrade the signal. But thankfully, it's one that we were able to overcome with the design of our probe arm and several of the individual components. Specifically, this solution uses special, low-loss, high-efficiency waveguides from Swiss-to-12 in a unique mechanical design that, when combined together and used with a custom-designed, cryogenically rated high-frequency probe, ensures the integrity of the high-frequency signal is maintained all the way from the extender head down to the device under test. So, now that the length of the signal path can be overcome, we can perform calibrated S-parameter and other high-frequency measurements in the Lakeshore probe stations, and all without significant changes to our probe station. As you can see here, we have the solution mounted on our CRX 4K, and it did not require any special modifications to the probe station itself. And the great thing is that we get this capability with all of the heat containment and standard cryogenic radiation shielding that we have in our standard stations. And now we have this with terahertz high-frequency probing in addition to our typical DC or RF probing. Now, the probes themselves used in this solution are specially engineered cryogenic version of the T-Wave probes developed by DMPI and sold by Cascade Microtech. These probes were specifically designed for the Lakeshore probe station to accommodate both thermal anchoring and an embedded temperature sensor. They feature low insertion loss coupling to the device under test and offer DC biasing of probe circuits. Different versions are available depending on the frequency band and probe pitch required for the type of coplanar wave device you want to measure. As far as applications go, we expect this probe arm to be an important tool for a number of researchers involved in early-stage electronic device R&D, especially for anyone needing a better way to characterize semiconductor materials used in new high-speed chip design. The cryogenic part is important because interrogating samples at low temperatures can reveal certain mechanisms that can't be seen at room temperature. We also expect to see a lot of interest by people studying millimeter wave, multiple layer, monolithic integrated circuits, and also MEMS devices, and those who are developing amplifiers and other components for use in quantum computing. And then there's radio astronomy. High-frequency probing in the millimeter, submillimeter, and terahertz bands should be of interest to scientists involved in developing new components like LNAs, as well as researchers trying to develop new solid-state detectors for operation up to terahertz frequencies. And even better, because the terahertz probe arm can be used on probe stations like our CPX-VF, which includes a vertical field magnet, you can also measure a sample as a function of high magnetic field, which may be beneficial if you need to perform broadband ferromagnetic measurements. Just to be clear though, at this time we have not completed the design of a fully non-magnetic probe body, so for measurements at variable magnetic fields, the probe tips must be raised when changing the magnetic field. The maximum number of terahertz arms that can be installed on a probe station is 2, with the 2 arms in positions 2 and 5 as shown here on the CRX-4K. Now the other probe arm positions can be used for typical DC, RF, or even optical excitations if needed. Currently, we offer 2 versions of the terahertz probe arm, a WR10 band model for probing 75 to 110 gigahertz operation, and a WR 5.1 version for 140 to 220 gigahertz operation. But other bands can be developed for higher frequency operation as applications push to those higher frequencies. As with other Lakeshore GSG-style probing configurations, you get 3-axis manipulation of the probe as well as theta planarization to ensure that the probe tips make good contact with the sample substrate. Here at the top of the arm, you can see there's a temperature sensor feed-through, which is used for making connection to that embedded temperature sensor in the probe and connecting it to our Lakeshore model temperature controller. There's also a DC bias port, which connects via a microcoaxial cable to the probe itself and is used for DC biasing of the device under test right through the GSG tip. This eliminates the need to bring in another DC probe just for that bias. The Lakeshore solution includes the verified probe arm assembly with a stainless steel welded bellows, encasing the high-frequency waveguide, as well as the micromanipulated stage itself. The solution is designed specifically for the Virginia diodes, also known as VDI, mini VNA extender heads, as shown here. This VNA extender is available in multiple transceiver configurations of full transmit-receive, transmit-only, or receive-only configuration, and the Lakeshore station accommodates all of them. Note that the Virginia diodes extender head is not included with the Lakeshore option. The cryogenic T-wave probes can be ordered directly from Cascade Microtech, and there is a good reason why we partnered with Cascade in this regard. High-frequency measurements are very complex, and the Cascade staff are experts in high-frequency calibrations, so it's only natural that we would have their support. This way, you're assured of a seamless, validated configuration and expert assistance with your specific research application. We also recommend using the Cascade WinCal software, which we have used through verification and validation testing, and it has proven to be a very highly effective, efficient, and repeatable tool for calibrating probes. The Virginia diodes extender heads work with most modern vector network signal analyzers, including those from Keysight Technologies. The PNA from Keysight, which is shown here in single port configuration, used with our Terahertz probe arm, is one that we used extensively in our own validation tests and sample measurements. So it's one that we recommend highly. We are an authorized solution partner of Keysight for a number of probe station related initiatives. So in working with them, we are well equipped to provide application support for our customers. And to close the loop further, Keysight, like Lakeshore, is a Measure 1 partner with Cascade, so you can count on a continuity of product support by companies who are quite familiar working with each other's technology. Everyone here at Lakeshore is excited about what this Terahertz arm offers to the research community and what new measurement and possibilities are available for next-generation electronics R&D. It truly is a breakthrough, and for any questions you might have about how it might be useful in your existing or new probe station application, please reach out to us by emailing us at sales@lakeshore.com. Thank you very much.